All right, so we had some requests to go over systems of equations problems, so I'm going to go through one of each type. Obviously, you can't ask questions. I'm going to go through this relatively quick. This is a lot of review, so hopefully it just kind of jogs your memory on what we've been doing. So substitution, I do because I have one of the equations that is equal to just y or x or one of the variables, which means I can take that and plug it in for y. So I'm going to take the top equation, 3x minus, but then I'm going to replace the y with 3x minus 2. So that goes in right there, and then I finish out the equation. Now this one's kind of a tricky one because a lot of times we forget that that minus is distributing inside of there. So I have to distribute next. Negative 1 times 3x is going to be negative 3x, and negative 1 times negative 2 is going to be positive 2. And now I solve for x. Okay. What happens with this one? This one's kind of unique because I get 3x minus 3x, which cancels them out, and it just leaves me with 2 equals 7. Now, 2 does not equal 7, so this one means that there is no solution. In the event that we were actually able to solve for x and find a value for x, we would then take that new value, we would come back up here and either put it in for this x and this x, and then we'd solve for y, because a system of equations needs both the x and the y. Okay? Hopefully that kind of sparks your memory just a little bit. All right, equal values method, very similar to substitution, except for this time both of them are equal to the same thing. They're both equal to x, so I'm going to make them both equal to each other. So I'm going to take negative 5y plus 2, and I'm just going to make that equal to 3y minus 2. Okay, so we're just going to put that there. All right, now I solve for y. I'm going to subtract 3 from both sides, or 3y from both sides. And I get negative 8y plus 2 equals negative 2. Subtract 2 from both sides. Divide both sides by negative 8, and I get y equals 1/2. I know I skipped a few steps there. Hopefully you can follow along. Okay. Now I'm going to take this y equals 1/2, and I'm going to put either 1/2 in for one of those two. So now I'm going to take, let's take the bottom one. X equals 3 times 1/2 minus 2, and then x equals 1.5 or 1.5 minus 2, so x equals minus 1/2. Okay, again, I know I skipped a few things there. This is my y, so I have negative 1/2 comma 1/2, and that's my ordered pair. Okay, so our last one is elimination. This is where, remember, we are going to draw a line underneath. We're going to either add or subtract both equations together in order to eliminate one of the variables. But the coefficient for those variables have to be either the same, like for example, you would need a 5x and a 5x, or they would have to be one positive and one negative of the same value, like 5x and negative 5x. We don't have that here, so we are going to change one of the equations to make that work. Through multiplying. So what I'm going to do is, I see this 3y here. I know if I multiply this 3 by 3, that would make it a 9, and then I could add that to negative 9 to cancel them out. So I'm going to take this whole equation up top, and I'm going to multiply it by 3. That gives me 15x plus 9y equals negative 18. And then this stays the same. 2x minus 9y equals 18. And now what I can do is I can add these together because those guys are going to cancel out. So 15 plus 2 is 17x. Negative 8, these cancel out, and these also cancel out. Negative 18 plus 18 is 0. I can still divide by 17, and I just get x equals 0. So now what I'm going to do is I'm going to take my 0, and I'm going to take it back up here, or here, and just use one of those equations to solve for y. So I'm just going to take the top one, 5 times 0. 8. 5 times 0 is 0. 3y equals negative 6. Divide both sides by 3, and I get y equals negative 2. So if y is negative 2 and x is 0, that is my final answer. All right, I hope this was helpful for you guys. I know it's something we did earlier in the year, and if you haven't done it in a while, it definitely requires a little bit of reminder to get going.